Okay, welcome back. Let's see if my voice will hold out. I'm trying my best to do it. But today you will name and use corresponding parts of congruent polygons, and you will prove triangles are congruent using the definition of congruence. Because you know y'all love proving so much. Anyways, let's move on to the next part, shall we? Okay, so if two polygons are in two congruent polygons, all the parts, so notice this, congruent polygons, all the parts of one polygon are congruent to the corresponding, I should say corresponding parts, are matching parts. Corresponding and matching mean like that, of the polygon. These corresponding parts include corresponding angles and sides. So, by definition, so this one is a definition. Two polygons are congruent if and only if their corresponding parts are congruent. So, like notice here, like the corresponding angles, A with A, or A with H, B with J, C with K, saying those angles are congruent. And then the sides, AB with HJ, BC with JK, that type of thing. Thus, because all the angles and all the sides are congruent, the triangles are congruent. But notice how they match that up. So notice here that they're saying triangle ABC is congruent to HJK. So it is okay to say triangle ABC in this example is congruent to HJK. It would be okay to say triangle BCA is congruent to JKH. Notice how I'm still keeping the angles that were congruent in the same spacing. It would not be okay, so not okay, let me put here not okay, not okay. It would not be okay to say triangle ABC is congruent to triangle JKH. Because now you're changing up the order. See, when you say like A, according to what you're saying, A matches up with H. B matches up with J. C matches up with K. Notice here I'm still keeping that. B matches up with J. C matches up with K. A matches up with H. But here I've changed that. So this is not okay when you change it up and you don't have corresponding parts listed together in the same order. Okay? So keep that in mind when you're talking about congruence. Okay, so I'm going to use this as an example, and I want to show that this polygon, the trapezoid ABCD, or that polygon ABCD, is congruent to WXYZ. Well, how do I do that? First off, I would have to list all the angles. So I would look at all the angles, and I could say angle A is congruent to angle W. I could say angle B is congruent to angle X. And you notice here that they have like double curves, so that kind of tells me which ones correspond to who. So pay attention to stuff like that. Angle C is correspondent to angle Y. Angle D is corresponding or congruent, to angle Z. Okay, then I have to do sides. So sides, I would have to say, like line segment AB is congruent to segment WX. Notice again, A with W, B with X. To keep the same order, you can't switch the order. Let's go with BC is congruent to XY. CD is congruent to YZ. DA, notice how I've gone completely around, is congruent to ZW. So now that I've shown all the sides and all the angles are congruent, since all angles and all sides I should say all corresponding angles. So I'm going to put in here corresponding I'm running out of space. You get the idea. Corresponding angles and sides. So it's all corresponding angles and corresponding sides are congruent, then, let's see here. I guess I'm going to say polygon ABCD is congruent to polygon WXYZ. Boom. There you go. Ba 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 ba. Ha ha. Very good. All right, so here's another example. This time, instead of trying to prove that they're congruent, I'm going to tell you that they're congruent, but now you got to find some missing values. Well, what do? I don't know. Let's see here. Okay, so let's go with this. Okay, so we now know, like, because of the way this is written, A goes with D, B goes with F, C goes with E. So I've got this right here, and I know it's equal to 99. So I can start off with that. 8y minus 5 is equal to 99, because those two are congruent. So if they're congruent, that means they're equal. So I can add 5 to both sides. And I get y is equal to, 8y is equal to 104. Okay, so if 8y is equal to 104 and then I divide by 8, I get y is equal to 13. Bam! Okay, so that one's that. So I now have the y. So now how do I find the x? Well, I know that this side, let's erase something here so y'all don't start getting too lost here. Okay, this side here and this side are congruent, and then I've got these 2 points here, or these 2 lengths, so I can put here 2y plus x is equal to 38.4. Now I know 13 is y, so I can say 2 times 13 plus x is equal to 38.4. 2 times 13 is 26, plus x is 38.4. They were really stuck with that whole 38.4 business, huh? Anyways, subtract out the 26, and I get x is equal to 12.4. And that would be the x. And that's very simple. That's as much as you need to do there. Okay, so, do we get a new theorem? Yes, we do. Okay, so the next theorem that we have is the third angles theorem, that if 2 angles of one triangle are congruent to 2 angles on a second triangle, excuse me, then the third angles of the triangle are congruent. That's kind of a duh. If 2 angles are already congruent from one triangle to another triangle, then because they all have to add up to 180, the third ones have to be also congruent. It's kind of like a, duh, you should know that. So, there you go. Now, we'll talk about the proving triangles part, the proving part in class, I think. That's something for us to work on because y'all have had some really difficult times with that. But let's do one more theorem and then we'll be done.